Hi, I'm Abigail C, and I'm going to tell you about our work on understanding and predicting user dissatisfaction in a neural generative chatbot. We're used to the typical dialogue evaluation setup that we see in papers. So you usually have a dialogue agent talking to a crowd worker, usually through a written conversation. The crowd worker has probably been given some instructions, telling them how to talk to the bot, what to talk about, and for how long. The crowd worker might even have been given a persona to play during the conversation. Lastly, the crowd worker has an extrinsic reward, some kind of payment for taking part in the conversation. We know that neural generative models are performing increasingly well in this kind of environment. However, in real life, if you're going to deploy a dialogue agent, it might be quite different. The dialogue agent might be having a written or a spoken conversation, not with a crowd worker, but with a user. The user has their own expectations for the conversation and their own personality. Especially if it's a spoken conversation, there's quite likely to be in a noisy environment as well. There'll probably be latency constraints, meaning you need the bot to respond quite quickly, otherwise it becomes difficult to uphold the conversation. Lastly, the user has an intrinsic reward. They have their own reasons for taking part in the conversation. Neural generative models are less well explored in this environment, and that's the focus of this work. Chirpy Cardinal 1.0 is an open domain social bot, which we built for the third Alexa Prize, which happened last year. In that competition, we won second place. During the competition, Alexa customers can speak through their Alexa devices to the participating social bots. The customers take part voluntarily. The bots need to be fast in order to talk to the customers, and they also need to be robust to the often noisy home environment in which the users are speaking. In this talk, I'm going to be telling you about just one component of Chirpy Cardinal, the neural chat component. Its job is to use a neural generative model to discuss the user's personal experiences and emotions. So within a conversation with Chirpy Cardinal, a part of it will be with the neural chat component, and it might look like this. The discussion starts off with a handwritten starter question, such as, how are you feeling today? We handwrite these starter questions to be open questions that are easy to answer without thinking too long. Other topics include things like hobbies, food, everyday activities, and family and friends. Once the user has answered that question, the next responses from the bot are written by a GPT-2 medium model, fine-tuned on empathetic dialogues dataset. The reason we use GPT-2 medium and not some larger version of GPT-2 was primarily due to latency and budget. The larger GPT-2 models were too slow to use in this setting or too expensive. The reason we use the empathetic dialogues dataset is because the empathetic tone of that dataset was similar to what we were aiming for, and also the topics that they cover are quite similar. So the conversation goes on like this, with the bot writing responses from GPT-2 medium. So the example given here is quite good. However, it doesn't always go very well. And when the conversation doesn't go well, users are quite likely to express dissatisfaction. So here are examples of all the different kinds of dissatisfaction that the users might express. So for example, the users might complain that the bot's being unclear or hasn't heard them correctly. They might say that the bot has asked an inappropriate question. They might complain that the bot's repeating. They might just generally criticize the bot or say something offensive, or they might say that they don't want to talk about this anymore. So those are the ways that the users sometimes express dissatisfaction. The next question is, what kinds of errors is the neural generative model making? So to understand this, we came up with a taxonomy of 7 main types of errors that we saw the generative model making. Firstly, repetition. This is when the bot says the same thing again. So here the bot asked, what are your plans today? The user says, I don't know. And we say, sorry to hear that. What will you do today? So although it's not word for word the same, it is essentially the same question. Next, redundant questions. Here the user said, I went jogging with my sister, and we say, sounds nice, do you have a sister? So we're asking for information that has already been given. Unclear utterances. For example, here the bot says, how's quarantine been for you? We say, it's been okay. Sorry, the user says, it's been okay, thanks. Then the bot says, I see, what is it? So this is an unclear utterance, meaning that it's hard to understand even what the bot is talking about, hard to understand the bot's meaning. Hallucination. Here the user says, I played Frisbee today, and the bot says, glad you had fun playing Frisbee with your dog. Here the dog has been hallucinated. So hallucination here means referring to something that wasn't mentioned. So sometimes the bot is actually responding to something that itself said earlier. So if the bot mentioned its own dog earlier, sometimes the bot mistakenly responds to its own utterance earlier in the context. Other times, like here, it seems as if the bot is perhaps echoing things that were typically seen in training. Next is ignoring. So here the user asks, do you have a boyfriend? And the bot says, I think boyfriends are great. How about you? So the problem here is that even though it was generally on topic, it has ignored the user's question and it hasn't answered it. Logical errors. Here the user said, my cat threw up on the couch, and we said, oh no, did you get a new cat? So a logical error we define as being an utterance that is generally on topic, however, it is making some kind of assumption or association that lacks common sense or understanding of the world. Lastly, insulting. This is when the bot says something that is unkind about the user. So here the user says, I'm feeling lonely, and we say, oh, I suppose you have no friends. So having understood these different kinds of errors that the bot is making, we next wanted to understand what are the main causes of user dissatisfaction. So to understand this, we did an annotation. We took examples from the conversations we had with users, and then we looked particularly at the neural generated bot utterances B, as shown here. And we annotated those for the different kinds of errors that the bot was making. We also looked at how users immediately responded to those utterances, and we annotated the different kinds of dissatisfaction that they were expressing. We also looked at the context C that came before, and we checked whether the user's utterance was clear given the transcription that we got from the ASR component. We also checked whether the user was already expressing dissatisfaction beforehand. So the examples we annotated gave these results. We found that 53% of the neural generated bot utterances contained some kind of error, which is definitely not good news. However, we did find that quite a lot, almost a quarter of the user utterances that came in the context were unclear, meaning given what was transcribed, the human annotator couldn't understand what the user meant. We also found that in 12% of contexts, the user was already dissatisfied. So taken together, these are challenging examples that are basically impossible for the generative model to resolve because it can't understand what the user is saying, or the user is already expressing dissatisfaction and it can't be handled by the generative model. So if we take away these very challenging, almost impossible examples, the orange bars show what's left. So we find that this does account for some of the more basic errors, such as repetition, unclear utterances, hallucination, and ignoring. Of what's left, redundant questions and logical errors are the most common. So I think this shows that focusing on getting neural generative models to use the history correctly and do reasoning and common sense more is definitely a good priority. So we've understood how common the different kind of bot errors are. The next question is, what's the connection between the bot errors and the users being dissatisfied afterwards? This plot shows the different kind of bot errors on the left and the ways that users express dissatisfaction afterwards on top. The check marks show significant positive correlations between the two using a likelihood ratio test. The first thing to notice is that all the different kinds of errors are correlated with some kind of dissatisfaction, except for logical error. So this means that bot logical errors are more tolerated by users than other kinds. I think there's a few reasons for this. One is that the logical errors are the least damaging to the conversation. They're not as confusing, they don't completely derail the conversation, they're not as annoying. In fact, some people seem to find them funny. So for example, if the cat threw up on the couch and then we say, did you get a new cat? Some people interpret that as a joke. And other users are quite kind to the bot. They actually choose to explain to the bot why its assumption was false or explain how the world works. Another pattern we found is that all of the different user dissatisfaction types correlate with the presence of bot errors, except for two. privacy and offensive. So offensive, that's when users just say offensive things. I think the reason why this is less correlated with errors is because users have a variety of reasons for saying offensive things. Sometimes people are just being mischievous or playful, or sometimes they are trying to test the bot to see what it can and can't talk about. So I think these behaviors can be fairly independent of whether the bot has made errors or not. As for privacy, I think the reason for this is because different users have very different expectations of what's the appropriate intimacy of the conversation. So for example, when we ask a question like, how are you feeling? There are some users who might respond very honestly and say something such as, I'm struggling with depression. And there are other users who, when asked quite an innocuous question, like, what did you have for lunch, might say, that's none of your business. So given that we have users like on the left and on the right and everywhere in between, I think this shows that it's quite subjective, really. Users have very different ideas of what's the right level of the conversation. So they might complain about the bot asking inappropriate questions pretty independently of whether the bot has actually made any errors or not. So we have looked at what might be causing user dissatisfaction. The next question is, can we predict user dissatisfaction before it even happens? If so, then maybe we can avoid causing it in the first place. So the way we do this is we train a dissatisfaction predictor to predict how dissatisfied the user's response will be. So given an example like this, we look at the user's response, what, and we get a dissatisfaction score for it. And this is provided by a classifier that we've trained. So here we're saying that when someone says what, it's pretty likely, 0.64, that they are dissatisfied. So having got that score from the classifier, we then train a dissatisfaction predictor to output the score 0.64 without seeing the utterance what. So the idea is that just given the conversation up to the bot's last utterance, we try to predict how likely it is that the user will respond to that with dissatisfaction or not. Having trained the dissatisfaction predictor, we can then use it to choose better bot utterances at test time. So, for example, if we're actually talking to the user live and the user says, okay, but my cat threw up on the couch, we might sample several different possible responses from the generative model. So as before, we have, oh no, did you get a new cat? We might have alternatives such as, oh no, did you clean it up? We can then take our dissatisfaction predictor and run it on each of the different possibilities. And for each one, it will predict how likely it is that the user would respond to that utterance with dissatisfaction. This means that we can choose the response that has the least likelihood of leading to dissatisfaction. So to check whether this worked, we ran a human preference test. So given some examples in our data set, we sampled 20 possible responses, and we compared the one that the predictor thought was best to a randomly chosen one. So we found that the predictor chosen one was preferred more often. So this shows that the dissatisfaction predictor can help us avoid poor quality bot utterances by predicting ahead whether the user is likely to be dissatisfied or not. So in summary, we found that real-life deployment can bring unique challenges. There are users who have their own expectations of the conversation, and they might be operating in quite noisy environments. They have their own intrinsic reasons for taking part in the conversation, and this might make them behave quite differently to crowd workers. There might be quite serious latency constraints on what you can do. Neurogenerative models fail if you just carelessly unleash them in these kinds of real-life settings. However, we found that some real-life challenges, such as user dissatisfaction, can also be really useful learning signals that help you to improve the dialogue model. If you're interested in learning more, please check out our paper. Thank you.